you were ever hot. Give us the retentive memory. Give us understanding that as we go through this revision, as we go through this process of revising the 100 questions in physics, the Lord will give you that deeper understanding, and you will consolidate your knowledge in physics. And your knowledge in physics will never evaporate. What you learn today will remain with you, will abide with you till you finish your university forever. Open your mouth and pray. Open your mouth and pray. In the mighty name of Jesus, I commit the children into your hand. And Lord, I pray that what they shall review today, they shall stick in their memory. Nothing shall take it away. The rest of the air will not take it away. The spirit will give them out. For life, for life, for life. Holy Spirit, do your work. Do your work of the children. Want them to excel. Give them the mindset of success. No, there has to be any man who has never worked for it, not wait for them. Receive the glory. In Jesus' name I pray. Amen. 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 Let me. All right. Good morning, everyone. Okay. Let me pray. Yes, sir. Father, in the name of Jesus, I thank you for the privilege. I thank you for this organization. I thank you for continuously leading us for the good of the children. Lord, I commit today into your name. For the scripture said, if it is the day the Lord has made, we shall be glad. Lord, I pray that these children, as they go through the revision, Lord, I pray they will be glad. They will be happy. They will be full of fulfillment and happiness and excitement. Lord Almighty, I pray, committing the teacher into your hand. Pray that you will give him the unusual understanding. That the way he will dissect, the way he will explain, the way he will review these qualifications with these children will have the cause to appreciate you, God. Lord, I pray that as they start, oh God, take away weakness, take away every, distractions that come with the mobile phones, that comes with every form of distraction, chatting while the grass is going on. Father, touch negative spirit, touch them out of their lives in Jesus' name. And that will be children to excel, and enable them to succeed. Receive the glory, receive the honor, receive the adoration. In Jesus' name we pray. Amen. Thank you, Chicken. Please, you can take it on from there. Thank you. I appreciate you. Thank you. Thank you. Thank you.
Thank you very much, sir. So good morning, everyone. I trust we are having a wonderful time, please. So I'm happy to be here again. I'll be happy to see you. So I'm going to be doing the revision of the 100 questions that you took a test in. So I'm sharing my screen now, and then let's dig right into it. Okay, I hope everyone can see my screen.
Yes, sir.
All right. Okay. So this is the test you took. Now, the first one says, which of the following quantities is scalar quantity? The first one is momentum. Second one is force, work, and acceleration. Now, first of all, we need to understand the meaning of the scalar quantity. I think most of us here are done the topic of scalars and vectors, but just in case, a scalar quantity is a quantity that has magnitude but no direction. That means it has numerical value, but it has no direction. So let's say, for example, speed. If you check your speedometer, will just say you're moving at 20 kilometers per hour, but it doesn't state the direction you're going in. That's a scalar quantity. Your mass, you just measure it. Say the mass is 50 kilograms. That's a scalar quantity. There's no direction. But a vector quantity, on the other hand, has magnitude and direction. That means in place of speed, we have velocity, which is the speed moving in a specified direction. So Unlike the first example where I said the speed is 20 kilometers per hour, for a vector quantity, it's going to be that the velocity is 20 kilometers per hour towards the east. Maybe I'm approaching a checkpoint. So I say, okay, he was speeding at 80 kilometers per hour towards the police checkpoint, and so he was arrested. So that's velocity. That's the vector quantity, of which the example I gave is velocity. So now let's now look at this example. First of all, momentum. Momentum is a product of mass and velocity, and so it's a vector quantity. Force is mass times acceleration. It acts in a particular direction. Of course, even momentum acts in a particular direction. Those of you in SS2 and 3 can relate, whereby you can have the velocity as negative, for example, which shows that it's moving in an opposite direction. If the velocity is positive, that means it's moving in the same direction. What I mean is, when two objects collide, sometimes they can rebound against each other. So if they continue to move in the same direction, then that means that velocity is positive for whichever object you're looking at. But if the object rebounds, that means it hits the other one and rolls back. The velocity will be negative. So that means in momentum, which is the product of mass and velocity, you are measuring a vector quantity. Now, force acts in a particular direction. You can be applying force on a piece of chair, on a piece of wood. So it is a vector quantity. Now, the answer is actually work, because work is said to be done, right? Work is said to be done when a force moves an object through a particular distance. Now, it's a tricky question anyways, because how is work a scalar quantity? Because work is a product of force, which is vector, and what? And displacement, which is another vector. But one thing you understand, and that's from further maths, is that the scalar product of the dot product of two vectors will give you a scalar quantity. That means if you have two vectors multiplying themselves to give you a vector, a scalar quantity. But let's just analyze it in logical terms. What is work? Work is just a measure of the amount of energy that is dispersed. True or false? Because when you move a force through a distance, you dispel an energy. So that means work in itself is just measuring the energy you dispel. It's not really measuring the direction. It doesn't really care. So the answer to that first question is actually C, work. I hope that's clear. Hello class, can we hear me?
Yes, so it's you.
All right. Now, the second question says that an object is projected horizontally from a height of 45 meters. Let me erase this. So an object is projected horizontally. Now, this is a test of our knowledge in projectile motion. A projectile is an object. I'm just defining it for the sake of, because I understand some people in SS1 here. I may not have done it, but basically from the word project, like when you say something is being projected. So a projectile is an object that is launched in the air and that moves under the effect of gravity. For example, when you fire a bomb from an airplane or a fighter jet, it drops the bomb and then it falls fully under gravity to the target. So now this question says that an object is projected horizontally. That's an horizontal projection. This is an horizontal projection. Let's say this is an horizontal projection, which is along the x-axis. So now, the height is 45 meters. It was projected from a height of, sorry, let me write this properly, from a height of 45 meters. And so, an initial velocity of 20 meters per second. Now, take acceleration due to gravity as 10 meters per second squared. So they're asking us, how far does it travel horizontally? That means when the object was projected from the top of this building, 25 meters, how far will it cover on the x-axis? So how do we get that? First of all, we need to understand that despite the fact that this is an horizontal projection, that this object is moving both in the x-axis and in the y-axis concurrently. This is what I mean. As this object was thrown, if you're looking at the direction I'm taking now, before it now fell at this point, you see that it's covering some distance at the x-axis. Also, at the same time, as it is being dropped, it's also falling through a height on the y-axis too. So it was projected horizontally, but it is still covering x and y components. So first of all, we need to get the time of the fall. So let's use our equation of motion. We know that S is equal to ut plus half at squared. This is one of the equations of uniform motion. But we know that considering the y-axis, which is your vertical direction, gravity works in that particular line. So as gravity works in that particular line, it's going to affect the initial speed or initial velocity. So initial velocity is going to be 0. So I'm going to have that S is equal to half. Then since it is falling, acceleration will be acceleration due to gravity times gt squared. So that will be the formula for the height. Now I know that the height is 45 meters. So I have that 45, which is the height, is equal to half times g, which is 10, times t squared. I don't know the time. Right? I don't know the time. But now if you notice, what they asked me to find is the distance it travels horizontally. But like I told you, like I told us, the object is covering both x and y component. That means as it's falling down, it's covering some distance on the x-axis, which is this distance, and at the same time, it is falling through a height in the y-axis. So that means it is happening in the same time. So we can use any of the components to actually get time. So for this case, I use the y component, which is this vertical axis where acceleration due to gravity acts upon. Gravity acts in the vertical direction. That's why any object that is thrown up will certainly come down. All right. So we can get the time. Sorry. That's t squared. So we can get the time. So from here, I'll have 45 is equal to 2 here is 1, 2 here is 5. 5t squared. So I can divide both sides by 5. 5 divided here 5. 5 divided here 9. So 9 is equal to t squared. Now we know that we can get t by taking square root of both sides, of which t will be equal to minus 3 or 3. But of course, time cannot be negative. So we're only going to take the positive answer, which is that time is equal to 3. But that's not what we're told to find. We're told to find the distance it covers horizontally. Now, the horizontal distance is the normal equation of motion you've been doing, like SS1. You did equation of motion. You also did velocity, time graph, distance, time graph. You can see there was no mention of acceleration because you are moving on a horizontal body where gravity does not act. It's only when you're going up that's when gravity acts on you. So if we're talking of a body accelerates, move with constant speed, then decelerates. It's all on maybe the road, for example. It's not going up, it's not flying up negatively. So we can now use our normal equations, which is that speed what's the velocity? Okay, so velocity is 20 meters per second. So speed is equal to distance over time. Now we know the velocity it was moving around, which is the speed, same thing as speed. It was 20. So from here, the speed is 20, which is equal to distance over time. What did we get at the time? The time was 3. So cross multiplying, you have that the distance is 60 meters moved in the horizontal direction. So the correct answer here is actually option D, 60 meters. I hope we got it. Did you get the explanation? Hello?
Yes, sir.
Yes, sir.
Now, The third question says a metal block of mass 2 kilogram requires 20,000 joules of heat to raise its temperature from 20 degrees Celsius to 70 degrees Celsius. Calculate its specific heat capacity. Now, what is specific capacity? First of all, anybody, what is specific heat capacity? Somebody. Yes, anybody? Who knows the definition of specific heat capacity? Yes. Well, somebody, at least I think those in SS3 have done it. I don't know if those in SS2 if you did it because you've only done first term. Let me see that. Okay, is there anybody in SS3 here? Okay, let me just define it so we don't dwell on that. Now, specific heat capacity is the quantity of heat that is required to raise 1 kilogram of a substance through a 1 degree rise in temperature. That means, what is the amount of heat that I need to raise 1 kilogram of a substance through a 1 degree rise in temperature? That means, at what interval will 1 kilogram be increasing its temperature gradually? Because, for example, if you attain a temperature of 100 degrees Celsius, it is a gradual process. Maybe the water was warm, maybe it was at 32 degrees, then you were boiling it gradually, 33, 34, 35, down to 100. So when we talk about specific heat capacity, we're checking how much heat do I need to continually raise the temperature of 1 kilogram of this substance through a degree of through a temperature change of 1 degree, whether in Kelvin or in Celsius. So the formula for specific heat capacity. Now, the formula for quantity of heat, first of all, is MC change in theta, where this is the specific heat capacity, this is the change in temperature. Now, the quantity of heat, as we are told in the question, it requires 20,000 joules, or you can call it 20 kilojoules. So let me call it 20 kilojoules. So this is 20 kilojoules is equal to, now what's the mass of the object? 2 times, I don't know the specific capacity. Now the temperature change, if something rises from 20 to 70, then that means the temperature change is 50. So I would have that, I'll have that 20 kilojoules, which is 20,000 joules, is equal to 100 times specific heat capacity. So dividing both sides by 100, I'll be left with 200. So the answer is that is 200 joules per kilogram per degree Celsius. So moving on to question 4. In question 4, they said the refractive index of glass is 1.5, and what's the question again? Okay, good. I'll be back. So it says the refractive index. This is now talking about waves. We have reflection, whereby you have a wave hitting a particular medium and being reflected, like your mirror. When your image hits the mirror, it reflects back your image. So this is incident ray, the ray coming upon the surface. This is a normal, and then this is the reflected ray. Now, we also have refraction, whereby as it moves from one medium to the other, it bends. So let's say it hits and then it bends. That's a refraction. Now, but the question says the refractive index of glass is 1.5. So refractive index is talking about what is the change, or how does it bend when it's moving from one medium to the other. Now, refractive index is represented by n, and is equal to the speed in that particular medium over the speed in a vacuum. Vacuum means where there is no air. Now, so the refractive index is 1.5, And so the speed of light is in a vacuum or a vacuum is 3 times 10 to the power of minus 8. 3 times 10 to the power of minus 8. So what is the speed of light in a glass? So the medium that this wave is passing through is actually glass. So we're looking for the speed in glass. So the answer is actually just going to be that I cross multiply. Are we with our calculators? So let's all type that in our calculators. 1.5 times 3 times 10 to the power of 8. All right. Oh, sorry. Sorry. The formula was in the inverse. I inverted the formula. Sorry. I inverted the formula. So the formula is actually speed in a vacuum, because that's where it will move faster, over speed in the particular medium, whether it's moving through water or through glass or through a metal. All right. So let's do that again. So the refractive index is 1.5 and the speed in a vacuum is 3 times 10 to the power of 8. Then divided by the speed in that medium, which is glass in this case, is moving through glass. So we're now going to have that. If I cross multiply, I will have 1.5 times the speed in glass, let me call it Lg, is equal to 3 times 10 to the power of minus 8. 3 times 10 to the power of minus 8. So to get the speed in glass, I have to divide both sides by 1.5. So the speed in glass will be equal to 3 times 10 to the power of minus 8 divided by 1.5. So somebody have 3 times 10 to the power of 8 divided by 1.5.
2 times 10 to the power of 8.
2 times 10 to the power of 8. All right. So that leaves us with option B as the answer. So do we understand? All right. Yes. So option B. Now, basically, what refraction is just checking is, light is behaves in a particular in different ways in different medium. If the medium is dense or if the medium is less dense, it can reduce in speed or increase in its speed. Like in a vacuum where there is no resistance, it's expected to move faster. But in a particular medium, it is now being affected because there's the medium now affects the way it moves. Maybe if it's a metal or if it is moving through water. So by we checking the refractive index, we're trying to say, okay, what is the ratio of the speed of light in a vacuum where we know it to be faster? The speed of light in a vacuum is fastest. And let's compare it when light is passing through different medium. For example, you can look at it that the rate at which water and light penetrates water is different from in the normal atmosphere. So this refractive index just checking the ratio, the speed of the light in different medium. All right. So the fifth question says, if the wavelength of a sound wave is 0.5 meter. Now, what is wavelength? Now, a wave is a disturbance that passes through a particular medium shared energy. Now, wavelength is the difference between two successive points in phase, right? So wavelength is 0.5. So this is wavelength. Now, V is equal to F times lambda is the formula for wavelength. Basically speaking, just I was speaking in terms of what's it called? In terms of wave. All right. So the speed, which is the velocity here, is equal to the frequency times lambda, which is the distance between two successive points. Now we're told that the wavelength is 0.5. So the wavelength is 0.5. Okay, looking at it, it's just a straightforward question. And the frequency is 630 Hz. Frequency means the number of revolution or vibration per unit time. So we're told to find the speed of the wave. It's just a simple, straightforward substitution. Now the speed v is equal to f times lambda. So we just do 680 times 0.5. So let's do it. 680 times 0.5. What does that give us?
34.
Or you can use the formula that was used familiar with either one of them. One over total resistance, one over total resistance, one over maybe resistor that is connected in parallel. So we can say one over our total or effective resistance or equivalent resistance. So the first one is 3 ohm, the second one is 6 ohm. That's the first methodology. We're going to get LCM of 3 and 6 is 6. So 6 divided by 3 is 2, 2 times 1 is 2, plus 6 divided by 6 is 1, 2 times, 1 times 1 is 1. So 1 over R total equals for the R. So we got 1 and 3 all over. So it's going to be 1 over 2 plus 3 will go here. 1, 3 will go here. Now to get the effective resistance, I have to do the impact. So this will impact over this also is over. So I have RT over 1 is the R. Well, of course, you can use this method shorter. So when the same thing applies, yes, the same thing applies for capacitors in series. For capacitors, create opposite resistors. For example, resistors that are connected in series, that's end to end, we just add them. Like for capacitor, if capacitor are connected in series, they're going to use this impact formula. So that means this other formula that I give you. So let's question 7. Now, let me say the transformer has 100 tons per micron out of 1,000 tons second ton. As far as what kind of transformer is it right now? What kind of transformer is it? Step down transformer. Step down transformer. Are you sure? Okay, why is it a step down transformer? I think because the lesser primary, the lesser core in the primary and more in the secondary. So that makes it step down. Okay, good, good. Any other question? Do you have anybody with a contrary answer or same answer? There's somebody else. Anyways, okay. Try because you have the idea that this is what you actually a step up. Then you get to reason. Okay, that's good. We try to find step up transformer. And step up transformer is crazy. So
primary studies right? Secondary studies yes. So for you to step up, that is whatever you know they give here, more studies, more yes. That is if you give less, but you have more. That is what more voltage. That is the step up. But
Oh, these things I didn't even notice I was out. Alright, so what questions do you stop hearing me from? Did you see the solution on to that number 6? Did we finish it together? Because I was on and I didn't even discover that network had cut me off.
So we stopped at that step up transform.
Okay. Did we finish the solution? Like I finished the solution, but was I on? Or do I have to go back?
So please go back.
Okay. You have to go back, sir. Okay. Wow, it was. I didn't even realize I was off because I was solving. I even started question 7, question 8. All right, let me just load it up on my notebook. Where are you? Where was it? Okay. Let me just do it again because I don't know it has wiped out of my notebook. So I was on that question of transformer, right? So I said that the question, the first question I asked was what type of transformer was that, and we established the fact that it was a step-up transformer because the number of turns in the primary, which is the input, is less than that in secondary, which is the output. So the formula for a transformer is that voltage in the secondary over voltage in the primary is equal to
EMF in the secondary.
Yes. Over number of primary. Right? I remember what I also said for the current. For the current is going to be inverse. So it's going to be number of turns in primary over number of turns in the secondary. All right, but since this question is in terms of voltage, so we're going to use the voltage formula. So looking at it, we are told to look for the secondary voltage, right? So secondary voltage is what we're looking for over. Now the voltage in the primary right here is 240. Is 240 is equal to now number of turns in the secondary, because that's what I need here. So number of turns in the secondary is how many? 1,000. Divided by number of turns in the primary is 100. So we move. So this is voltage in the secondary is 240 over these two zeros cancel each other. So I have 10. So I can now cross multiply. You will now have Vs, which is voltage in secondary, is equal to 240 times 10, which is 2,400. Now you can see that, just as I said in the beginning, indeed this is a step-up transformer because initially, what was the voltage in the input? It was 240. Now what was being produced on the output? 2,400. So that means the voltage was stepped up from 240 to 2,400. Thus proving that indeed it is a step-up transformer. So then the question 8 says that if a body is performing simple harmonic motion, its acceleration is always directed towards the dash. Now the answer to that question is basically in the definition of simple harmonic motion. And what is simple harmonic motion? Simple harmonic motion is, why is it reconnected? Can we hear me?
Yes, sir.
Okay. So
Yes, sir.
all right, thank you.
Yes, sir.
All right. I just needed to be sure because I was seeing reconnecting here. I was like, what's going on? All right, so simple harmonic motion. Yes, let me just throw it open to us. What's simple harmonic motion? Yes, somebody now. I believe that there are sets of people who have done simple harmonic motion here. Or should I call names? Should I do it that way? Okay, wait, let me come to the class. Should I call names? Someone should just help us out. So help us out. What's simple harmonic motion?
Simple harmonic motion is the repetitive to and fro movement of an object with a constant force.
Okay, that's good. All right, good. So, yes, it's a to and fro movement or a periodic or harmonic movement of a body, right? So let's even make it make sense. So basically, you can say, sorry. So you can say that simple harmonic motion is the periodic motion of an object in which its acceleration is directly proportional to its displacement and is directed towards its equilibrium position. Let's make it make sense. Let's use the most popular examples of periodic of simple harmonic motion. And what's the most popular example of an object that undergoes this kind of motion? Somebody, what object is most widely used?
Pendulum bob.
Exactly, pendulum bob. Thank you. So this is a pendulum bob. In those days, because these are the means of measuring time. So when you have this pendulum bob and then you take it to this point and then you swing it, you notice something, that the acceleration is always directed towards this point. That means the bob is always seeking to return back to its equilibrium position. That's why after a while, it swings and swings and swings and swings and swings until it finally comes back to this equilibrium position. So that means the acceleration is directed towards the center or the equilibrium position or the position of rest, and it is directly proportional to the motion. So already in that definition, I've already defined it. So what's the answer to question 8? Yes, who can deduce the answer to question 8? First of all, are we together?
Yes, sir.
Okay, good. So I said from what I've just said, who can deduce the answer to question 8? What's going on? Why is my not keep wiping off? Yes, anybody? Well, the answer is equilibrium position, because I've explained. I said in the case of a pendulum bob, the bob, swings by to and fro, like someone rightly said. It swings to and fro, and ultimately comes to rest at this equilibrium position or the starting point. Are you getting me? So the starting point is this equilibrium. I'm not saying that it's called starting point, but that's where the bob was originally, right? So initially. So that means the acceleration is always directed towards this center point where it started. So that means among our options here, what's the answer? The answer is what? The equilibrium position or the position of rest. Yes. So let's move on. We can solve this next question in 2 ways. It says the half-life of a radioactive substance is 4 days. Now, what's half-life? Half-life is the time taken for half of a radioactive material to disintegrate. And now, I told that the half-life is 4 days. That means after 4 days, now they say what? How many will remain after 16 days? So that means if there was n, after 4 days, let's do it step by step. This is the first half-life. That means in the first half-life, it will reduce to half. So it will be n over 2. That's the first half-life. We're going to 16 days. How many 4s are in 16? 4. So after another 4 days, it will divide by 2 again, which is n over 4. After another 4 days, it will divide by 2 again, which is n over 2. After another 4 days, to be n over 16. So that means what fraction will remain is going to be 1 over 16. Or we can use a formula for it. we can see, let us first check how many half-lives this radioactive substance can undergo. That means it to be 16 divided by 4. So that means how many times would we be able to have that half-life? It is going to be 4 times. So to get the fraction that is going to be remaining, the formula is 1 over 2 raised to the power of number of half-lives, of which this one has 4 half-lives from what we calculated. So it's going to be 1 over 2 raised to the power of 4, which is 1 raised to the power of 4 is 1 over 2 raised to the power of 4 is 16, which gives the same answer as before. So the correct option to this is option C. Okay, good. Now we have question 10. It says, which of the following describes the image formed by a plane mirror? So this one should be easy. What's the answer? Yes, somebody. What's the answer?
Real, inverted, and same size.
Real, inverted, and same size. Okay. Does somebody else have a different answer?
That's correct.
All right. So we have a plane mirror, which is our normal mirror that we use for our day-to-day activities. Now, are you sure the image is inverted? Plane mirror.
So, but what about C? But
Yes,
the image is not diminished.
Yes, it's not diminished.
So it should probably be A.
Okay. So that means what are answers that we're having? We have sorry, the first person, what did you say? You said option what? What was the option that you picked?
Option A.
Okay, option A. Is there any other contrary answer from any other person?
So I go for option A.
Okay, good. Now, the characteristic of images formed by a plane mirror is that, first of all, it is the same size, right? It is the same size, which is represented in option A. It is virtual, of which option A says real. The image formed by a plane mirror is not real. Do you know what it means for an image to be real?
No.
Okay. Now, basically, a real image is an image that can be projected onto a screen. That means the image is formed in front of the mirror, of which that's not the case. A very good example is a projector, yes. In a projector, the image from within the projector is formed outside. That's why you see churches that want to host a Christmas program, or maybe they want to do a movie night. They use a projector so that the image can be projected in front. But for a real image, the image is projected at the back. Are you getting me? Which is at the back of the surface of the mirror. That's why the mirror is polished at the other end. Are you getting me? And that kind of image is called a virtual image. So that knocks out option A. So do you want to try again? Do you understand the explanation why I gave that option A is not correct?
Yes, sir. So I'll go for option D.
Okay, somebody has gone with option D. The rest of us, what are we going with? Okay, okay, good. Yes, I think we finally got it. So the answer is option D, correct. Now, it is erect, of course. In your plane mirror, your image is erect. Then there are other options. There are other properties that are not mentioned here. Like, for example, it is laterally inverted. Lateral means on a straight line. That means, like in your mirror, if you raise your left hand, it's your right hand that is going to be raised on the mirror, right? So that's what it means by laterally inverted. So the answer is actually option D. So in general, the total characteristics of images formed by a plane mirror is that it is the same size as the object. Of course, is the same size as the object. It is virtual, which means it is formed at the back. It's not a real image that can be projected to the front. It is laterally inverted, which means if you raise your left hand, it's going to increase. It's your right hand that is going to be raised in the image. And that's like, for example, even in your camera, if your camera uses mirror mode, if you write something, or you snap your right, and it's going to be written from right to the left instead of left to the right. So also it is upright. It's not an inverted image. It is upright. So okay, that solves that. Now, question 11 says, which of the following pairs of quantities is fundamental only? Of which I think everybody now will be able to answer this one. What are the pairs of quantities that are fundamental only?
Length.
Time
Time
and
and
length.
length.
Exactly. We have 7 fundamental quantities, of which 3 are most commonly used, which are mass, length, and time. So here in this question, the answer is time and length. Question 12. The rising of liquids in an open-ended tube, the falling and rising, is not osmosis. There is no biology. So normally that knocks out osmosis. Now, adhesion is the force of attraction between 2 molecules of different substances. For example, the way when you pour water into a glass and then the water molecules, after you've drank water, you see some water molecules attached to the glass. That is adhesion. While cohesion is the force of attraction between molecules of the same substance, binding them together. So osmosis is out, adhesion is out. Now we're left with capillarity and surface tension. Now, surface tension is the property of a fluid that enables it to behave like an elastic skin. For example, when you are washing, you can notice that you can see insects walking on water, right? You can see something like mosquitoes.
The answer is C.
Yes, the answer is C, capillarity. So surface tension is knocked out. So the answer is C. Now, question 13 says, which of the following is equivalent to watt? Now, what is watt? Watt is the unit of power, and power is work done over time taken. So power is work over time. So we just derive the. Now, work is force times distance. Force times distance all over time, of which force is mass times acceleration. Force is mass times acceleration, then times distance, then all over time. So, looking at it, which of these options match? Wow, this is for me mad over here. Okay. So the unit for mass is kilogram. The unit for acceleration is meter per second squared. Unit for distance is what? Meters. The unit for time is seconds. So let's move it together. So meter times meter is meter squared. S is power minus 2 divided by S is power of minus 3. So this is kilogram meter squared per second cube, which is option B. So question 14 says the slope of a linear time graph represent dash. This is why we did it during our holiday lessons. Please, somebody who can help us. I want SS1 to actually answer this one. Acceleration. Okay. Wait, depends on the answer. Is that blessing?
Yes, sir.
Okay. So you picked acceleration. Is there somebody else with another answer? What? Okay, from any class. Do you have any, or is that the answer you chose? Okay, velocity. Okay. Now, okay, I'm just even saying something now. Even while comparing it, but I didn't. Oh, really. Well, it's not hard, of course, but it's just set in a tricky way. And notice what they said. They said distance time graph. So somebody actually said velocity. Yes. Wait, sorry, somebody's mic is disturbing us. Okay. So can we go on? All right, I think we're good. So somebody actually said velocity. Okay, we can go on now, right? Okay, good. Now somebody said velocity. Now, you would have been correct. But the issue is that it is measuring distance over time. So it is scalar. So that means the slope will also be scalar. So let me explain. This is a distance time graph. Now, slope is measured as in change in y over change in s. So that means we are having distance over time. We're having distance over time because it's called the distance time graph. Now, what is distance over time? It is speed, which is the slope. Slope is y over x, right? Of which, since they said distance time graph, you plot y-axis over x-axis. So that means for a distance time graph, you are plotting distance over time to get the slope, and speed is what you call the distance over time. So the answer is speed, actually. Velocity is only correct if they said displacement time graph. In displacement, you now have velocity displacement over time. So the answer is actually speed. All right. So just to be careful for those kind of tricky situations. So let's go on to the next one, question 15. Question 15 says, a body of mass 2 kilograms, sorry. So a body of mass 2 kilograms is released, I think I can see this space. Okay, there's a space here. Is released from rest on a smooth plane, inclined at an angle of 30 degrees to the horizontal. Now this is a body of mass 2 kilograms. So the weight is acting downward. Weight is mg, which is 2 times 10, 20. So normally, the force pushing it down is equal to mg sine theta. Well, we can't really derive that now. There's no time. While the normal reaction, which is to support weight, is given by mg cos theta. So what did they say? We should find. Say calculate the acceleration of the body down the plane. Now, this is the force that is sliding it down is mg sine theta. Now remember, force is mass times acceleration. So here is still mass. But in place of acceleration, we have g sine theta. So that means the acceleration is going to be equal to g sine theta. Do you get what I just said, or what I just said? All right. So that's now going to give me 10 times sine theta, which is sine 60, which is over 3 over 2. So what is that going to give me? That should give me a decimal. If I'm looking at it, the answer should be 8.7, because the other options are, there's no way with 3 over 2 will give you 8.2 or 8.1. But let's confirm from a calculator, please. I may let's not just assume. So 10 times sine theta, which times 60. Okay, yes, it's correct. It is 8.66, which is going to be 8.7 meter per second squared. Good. Yes, thank you very much. So question 16 says a ball is dropped from rest from the top of a 20 meters high building. What is its speed just before it hits the ground? Now, just before it hits the ground, we need to understand what's going on. Let's say a body, like the way you have trees, and you have maybe coconut or whatever fruit that may be on the tree. At some point, they will just drop, right? So what happens is that initially, when they were at rest, they had potential energy. So when they drop, just before they hit the ground, their potential energy was converted to kinetic energy. That means, now this one is brought from rest. That means it was initially at rest, potential energy. This is the body energy possessed by body at rest. And then it was now dropped, which means its potential energy was converted to kinetic, which is half mv squared. Now m is here, m is here. What is we should find? The speed, which is equal in magnitude to the velocity. So what I do, I cross multiply here. 2 times gh. I'll have v squared is equal to 2gh, of which my v will be equal to square root of 2gh. So it's going to give me 2 times 10 times, what is the height? 20, which is 400. So square root of 400 is actually 20. So the answer is 20 meter per second squared. Question 17 says, which of the following statements correctly describes the difference between mass and weight? Now let's see. Mass depends on gravity, weight does not. No. Mass does not depend on gravity. Mass is just simply the amount of matter that make up a particular body. The mass is a force, definitely not. Mass is not a force. Weight instead is a force, because weight has to be acted upon. For you to get weight, you have to consider acceleration due to gravity, which is the acceleration that the earth is to pull you towards its center due to its force of gravity acting on you. So mass is measured in kilogram and weight is measured in Newton. That's the answer. D says mass cannot change. Mass, of course not. Mass cannot change, but weight never changes. Not true. Weight can change, because weight is m times g, right? M times g. So that means when you're on the earth, g is the acceleration due to gravity on the earth. When you're on the moon, g will be acceleration due to gravity on the moon. So weight changes. So the answer is actually option C. Mass is measured in kilogram, weight is measured in Newton. Now question 18. So what this is about, I'll give you the density at 800 kilogram per meter cube. We have the mass over the velocity. Sorry, volume 2.5 meter cube. So to get the mass, you just cross multiply. So the mass is 800 times 800. So that should be 2.5 divided by 2. So 2 is 400 times 5 is 2,000. So that's option A. Option A correct. Now question 19. That's question 19. It says a simple machine multiplies force by 5. What does it mean to multiply force? Multiplying force is talking about what? Who has an idea? When you say something multiplies force, what is it talking about? What system in a machine is it talking about? The effort. Yes, it says it multiplies force. So yes, that to do with the effort, but there's a term, a particular term in the machine that is very mechanical advantage. Exactly, mechanical advantage. Yes, mechanical advantage. Because mechanical advantage is your output, work output over work input, right? That means when you put in your input, what becomes the output. So since it says multiply force by 5, that means there's an output. Mechanical advantage, the ratio of the output to the input is 5 to 1. That means if mechanical advantage is high, that means the machine is doing work very well. That means as you put in an effort of 1, it multiplies to give an output of 5. So now that the efficiency is 80%, so efficiency basically is mechanical advantage over velocity ratio times 100%. So now the efficiency is 8. The efficiency is 8. And the mechanical advantage is 5 over velocity ratio times 100. So let's just divide it. That 8 over 10 is 0.6. Sorry. I do not say 5. So this is 80 is equal to mechanical advantage. Sorry. Mechanical advantage here is 5 over velocity ratio. I don't know if you get 1,000. So 0 and 0. So I'll not be left with 8 is equal to 5 times 10 is 50 over velocity ratio. So here's velocity ratio from multiply. So that means velocity ratio is now 50 over 8. 2 year 4, 2 year 2 is 5. Now 4 year 6, remainder 1, of which 4 year is 2, remainder 2, 4 year is 5, 6.25. So the velocity ratio is 6. Yes, option C. 6.25. Is it clear? Alright.
So please can you go over the explanation?
Okay. Now,
So please can you go over it again?
yes, I heard you. What part do you need clarity on? Or you need just overall, like, I need what part?
So only the calculation part.
So let's do it.
Only the calculation
efficiency is mechanical advantage over velocity ratio as 100%. Right? So mechanical advantage is also multiply 5 is mechanical advantage over velocity ratio as 100%. Now why I'm going to this is because yes. So at this point I said 0 cancel 0. Now why as we need to advance for then once you have the same thing, maybe at the numerator you can start dividing even those opposite sides. That was like this. So 0 here can cancel 0. Alright, so both of them are integrated. Denominator, let's say from half 20 and half 10 here, you can do the same. Alright. Also learn velocity ratio is equal to 5 times 10 here, which is 8. So to get my velocity ratio, I will divide both sides by 8, of which gave us a velocity ratio 6.25. Then after. Yes, sir. Thanks, sir. Right, welcome. So question 20 says, when a metal rod is heated, which of these is true? Number 1 says linear. Come on. Number 1 says linear expansion is directly proportional to the rise in temperature. What is get that? I'll say the level of this is that the other should come. So let's go with it. It says volume contraction occurs. No. First of all, there's an expansion. So when you heat up the substance, you expand first before when you not cool, you not contract. So there's no contraction. They said the mass of the rod increases, mass never changes. We even get by looking at the function. The density increases, there's no the answer is actually that the linear expansion is directly proportional to the rise in temperature. That means the more temperature you apply, the more it's going to expand. Alright. So now question 21 says, what is latent heat of diffusion? Now latent heat normally is hidden heat, right? Is heat that is required to change a substance. You don't need the temperature to. For example, if I bring ice water or block, and I put it on the table, without me applying it, that block is going to melt into water. So that means with or without the heat, there is hidden heat that enables substances to change their state. So latent heat of fusion. Now fusion from what fuse? It simply needs to harden, of which in physics we also look at the opposite. It's either water is becoming ice, which is water fusing, become ice. Or so latent heat of fusion is actually the heat required to change the temperature of the substance from liquid to solid. Also, I can't believe someone saying something. Please, can you repeat yourself? I didn't hear you. But please continue. Okay. Now, latent heat of fusion, right? Like I've explained, latent heat normally is the heat that is required to change the state of now there's also specific latent heat, which is the heat that is required to change 1 kilogram of the substance. But normally in physics, we usually use latent heat and specific latent heat as the same because we use 1 kilogram normally as that means latent heat is the same as the heat that is required to change 1 kilogram of the substance from liquid to solid or from solid to liquid. So which of these is correct? Since it's chicken B, yeah, that means it must be that's from solid to liquid because I can't see the end of the question. I don't know whether it's because my screen. Okay, let me increase my screen. Okay, yes, that's why. So it is the heat that is required to change 1 kilogram of the substance from solid to liquid. Yes, that's what is there. That's option B. Remember, I said fusion. So that's what liquid is fusing into something solid, or that solid that was gotten from the liquid is melting back into the liquid. So question 22. It's a test on elasticity. So it said a steel spring with stretch by 0.1 is 0.1 meters. How much potential energy is stored in it? Alright. So this question says that a steel spring with a spring constant is stretched by 0.1 meters, and we're told to calculate how much is 0.67. Question was it 23? Now, question 24. Question 24 says light is what do you think the answer is? Yes. Pen was normal, okay? Someone said pen was normal. How the rest of us? What do you think the answer is? Yes, please, let's all be right.
Bends away from the normal.
Okay. Somebody else said, is that the same person or somebody else?
The same person.
Okay, so why did you change your answer? Why is this same? Why did you change your answer? What happened?
Like, don't see the future, please.
Yeah, that's what I'm trying to get. I don't know why it's okay. Yeah, so this is the question now. There's light going from water to air. Will dash? Will it bend away from normal, bend towards normal, continue on deviated, or will it be totally internally reflected? Here's the question. So what do you go with? Yes. Please, what about the rest? I want us to all interact, please. Yeah, so what's your answer? You said you want to see the question, so there it is. So what's your, are you still sticking with the other one? Okay, you said it bends away from the normal. All right, somebody else, please. Does somebody else have a yes? I can't hear. What about the rest? The rest of people in the class?
I think the answer is that bends away from the normal.
Now then, we are told that light is moving from which medium? From water into another medium, which is air. Now, first of all, before I proceed, which of them is denser than the other? Between water and water. As it's moving from a denser medium into a what? A better. So the answer is actually likely to tend away from the normal. So as it's moving into that medium from a denser medium, that is the normal, it's going to bend away from there. So the answer is actually option A. So do you understand? Are we there? Are we together?
Yes, sir.
Oh. So that's the answer. The answer is that it's going to bend away from the normal. So let's go to the next question. Question 25. Question 25 says a converging lens has a focal length of 10 centimeters. So focal length. So focal length is 10 centimeters. Then we are now told to find where the image of an object placed 30 centimeters from the lens. Where would the image be formed? Alright. So where would the image of that object be formed if it is between 30 centimeters from the object? Alright, so we're going to use yes. Did somebody say something? So can I continue? Okay. So I'm going to use the formula for a mirror or lens. So we have that 1 over f is equal to 1 over v plus 1 over u. So we now have focal length is 10, 1 over 10 is equal to 1 over v, right? Plus 1 over u, which is 30. So to get 1 over v, it's going to be 1 over 10 minus 1 over 30. Alright. Okay, let's just solve to ascertain that. So 1 over 10 minus 1 over 30 is equal to 1 over v. So 3 minus 1 is 2 over 30 is 1 over v. Okay, yes. The answer is 15 centimeter on the other side. Yes, that's correct. 15 centimeter on the other side is correct. Now, let me ask a question. Now, when the question says that it forms an image on the other side, what kind of image is that?
The virtual image.
Exactly, virtual image. Other side means at the back. So it's a virtual image. Alright, so question 26 now says 3 resistors of 4 ohms, 6 ohms, and 12 ohms are connected in series to a 12 volts battery. So first of all, we need to get the effective resistance. So for series, like I've said, series are connected end to end. So you just add. So that'll be 4 plus 6, 10 plus 12 is actually what? It's actually 24, yes. So it is connected to a 12 volts battery. So the voltage in this circuit is 12 volts. So we are now told we're now told to calculate the current that is flowing in this particular circuit. Now V is equal to I R, same voltage, right? So V here is 12 is equal to I times R. What is the effective resistance here? 24. So dividing both sides by 24, I'll have 12 here 1, 12 here 2. So 1 divided by 2 is actually 0.5. So the answer is 0.5 amperes for question 26. 0.5 amperes. Now question 27, very, very easy. Light poles repel themselves. So the answer is just repulsive. Unlike poles attract, but since it's light poles, they repel themselves. Now question 28 says that a coil is moved faster into a magnetic field. Have you done magnetic field or electromagnetic field? No, it's necessary. No, it's necessary. All right, good. So that means we have base knowledge to answer this. All right, so let's go on to answer the question. So we are told that a coil is moved faster into a magnetic field and induces a current of what? Of 2 amperes. Now, basically, we need to go back to Faraday's law of electromagnetic induction. And what does it state? It says that the magnitude of an induced electromotive force in a coil is directly proportional to the rate of change of magnetic flux. So that means what Faraday was saying basically is that the induced current depends on how fast the magnetic flux changes. As I said, the magnitude of the induced electromotive force is directly proportional to the rate of change. So if the rate of change is very, very high, that means if it's changing fast, if it's being induced fast, what happens if the magnetic flux is moving fast? What happens to the induced EMF? It becomes faster. So since from our question 28, the coil is moved faster into the magnetic field and it induces a current of 2 amperes. Now if it is induced faster, what's going to happen to the induced current? What's it going to be? It's going to become greater, right? So that means the answer is going to be more than 2 amperes. Since at a particular speed, it was 2 amperes. If the magnetic flux is increased, what happens? Induced what? Induced electromotive force becomes increased too. So the answer is more than 2 amperes. So question 29. Question 29. This one too is simple. It involves the same formula that we've used before. But wait, what kind of transformer is this?
Step down. Step down.
Exactly, it's a step down transformer because the number of coils in the primary is actually more than that in the secondary. So the second is the output voltage. So that means the output voltage has to be small. My bet is that it is going to be among all the options, since it has to be relatively small and it will be a factor. Notice it's usually going to be a factor because so basically the answer should be 80 volts. No, you're in an exam hall. I mean, yes, you're in an exam hall. Maybe there's no time you can actually smart get some answer. There's some question you can smart get because if you notice the ratio of the coins of the turns rather both in primary and secondary are factors of each other. Maybe there's 12 here, 24 on the other one, there's 60 here, there's 30 on the other one. So since number one, first one is more than the second, so I know that the voltage is going to be stepped down. So that means first of all, 720 is out. And it's going to be stepped down by a significant number. So 200 is also out. Now also, I know that the number of turns are usually factors of each other. So since the primary coil is what? 1/3 of the what? Of the output. So that means the output voltage too. So since the output on the secondary turn is 1/3 of the 600 because 200 is 1/3 of 600. That means the output voltage too will be 1/3, which is 80 volts. If you like, you can see it from okay, like 80. So question 30 says a radioactive sample has a half-life of 5 years. What's formula. That means in 50 years it will undergo 3 half-lives. So to know the fraction that will remain to be 1 over 2 raised to the power of n, which is 1 over 2 raised to the power of 3, which is 1 over 8. Or you can just take it and disintegrate it. After the first 5 years, to remain 2, to be divided into half. The next 5 years, to be divided into another half. The next 5 years, to be divided into another half. So the answer is 1 over 8. Now question 31 says, which form of radiation has no mass and no charge? What's the answer? Gamma, exactly. Gamma has no mass rather, and no charge. That's why they have high penetrative ability. So the answer is gamma. Now, question 32 says, a pendulum has a length of 1 meter. What is its period? Now, what is the formula for period of a pendulum? It is 2 pi square root of L over G. So, let's go on. It's going to be 2 pi times square root of, they said the length is 1 over, what is G? 10. So let's do that on our calculator. Just now, your calculator, what I expect you to do is just to use pi like that as it is, because we're not giving the value of pi, so I can't use 0.1421. So on my calculator, I'm just going to use pi. Oh, please, why am I only okay? That's common. 2 pi times square root of 1 over 10. So it gives me 1.986. 1.986. So which option here? It has to be option B, because 1.98 being approximated is 2. So now question 33 says the photoelectric effect. Now what is the photoelectric effect? Now the photoelectric effect tells us or shows us that light ejects electron when it has enough frequency, right? When it has enough frequency to eject that electron. So this proves that light transfers energy in discrete packets that are called photons. You know, we have what is called wave particle duality. Light has that ability to be a wave and at the same time to be a particle. So let's see the option. It says light behaves only as a wave. That's incorrect. Because I said light is both a wave, it carries energy because it can emit energy in form of photons. And it's also what? It's also a particle. So light energy is carried in packet called photons. That's true. That's true. Good. It says electrons have no binding energy. That's not true. Because binding energy is needed to keep close together. Then frequency does not affect emission. That's also not true. Because I said that for light to emit what? Electrons, the frequency has to be high enough. So the only correct option here is that light energy is carried in packets that are called photons. Do you understand?
No, sir.
All right. So what points are you confused about?
That the question is that I don't understand it.
Okay. Sorry. What class are you?
SS3.
Okay. Have you not done okay, you just did first term. Okay. That's where the issue is coming from. Now this is a topic I think you do in second term, which is wave particle paradox. So that means nobody has an idea of this particular question, right? Okay, good. So let me just explain. Let me just try and summarize it to us. All right. Let me just try and summarize it to us because we've not yet done the topic. You do it in second term anyways. So now, in the photoelectric effect, now what is the photoelectric effect telling us? It says that when light, that's why I think what you have an idea of this thing. Now in basic tech, if I'm not mistaken, or okay, no, it will not be tech. Now in basic technology, in I think GSS3, we talked about emissions, we talked about thermionic emissions, photoelectric emissions, and the like. So now this one is photoelectric effect. Now, photoelectric effect is telling us that when light shines on a metal surface, that it can eject electrons. Do you understand? So when light shines on a particular metal surface, that metal can eject electrons. I will now notice that for that electron to be ejected from metal surface, there is a particular frequency that light will be coming in for this to be able to force that metal surface to do what? To release those electrons. So basically, that's what the photoelectric effect is talking about. It's talking about how does light shine on a particular metal surface, causing that metal surface to eject an electron. And so by that property, we can now say that light is both a wave. You dealt with light with your SS2, you looked at mirrors, lenses, you saw the behavior of light. Then that's light as a wave. So in the photoelectric effect, we also see that light can also be what? A particle. Because as a particle, it releases electron from metal surface in form of photons. You get me? So those a wave transfers energy. So those energies are carried by the light particles, which are called photons. Do you understand? Are you getting the idea of what I'm saying?
Yes, sir.
All right. So first of all, in your SS2, you looked at light as a wave. All right. So now in your SS3 second thing, you're also now going to look at light as a particle. That light can shine on a metal surface at a particular frequency and then release electrons. So those are particles that are actually carrying the energy that you are seeing as light energy. So basically, it's telling us that light can be both a wave and a particle. So as a wave, you know it as light wave, right? So as an energy, that energy is being carried by the part called photons, and you can only see them at a particular frequency. That's why you don't just see light as a particle, your common light, because they are not at that frequency. You don't see them as a particle. You only see them as a wave. But when the particular frequency is at the end, you now see the particular particles that make up that light wave. That's true.
Yes, sir.
Yes, the answer is B. Yes. All right. So now Coulomb's law is part of a group of laws we call the inverse square law. It states that the force of attraction or repulsion between two charges is directly proportional to the product of their charges and inversely proportional to the square of the distance. So let's see question 34. Which of them is? It says proportional to their masses. No. Proportional to the product of their charges and inversely proportionally increases. I'm not sure because I don't think we let me show like this. The right option is this time. Yes, so it is proportional to the product of their charge and to the square of their distance of separation. So the answer is option B, according to Coulomb's law. The other one, the other inverse square law is, you can tell me the other one. Who can tell me the other inverse square law?
Is it the one for gravitation?
Yes, that's the other one. Where the force of attraction is directly proportional to the product of their masses and inversely proportional to the square of their distance. So here, there is a constant here. Here, there's a constant which is the universal gravitational constant. So the two of them are called the inverse square laws. So let's go on. It says, we answer question 34 now. Now, 35 says, what is the SI unit of potential difference? Basically, it is the volts. Potential difference is the volt. It is the energy required to move an electron from one point to another point in an electric circuit. So it is measured in volts. Now, looking at this, it says the diagram above illustrates the motion of a cyclist from P to R. The distance traveled is determined by a dash. We also dealt with it in our holiday class. I said that the area of a velocity time graph, in area here, right, is equal to length times breadth, of which in a velocity time graph, what is the length? It is velocity. And what is the breadth? It is time. So what is going to give us what? Velocity times graph. Velocity times graph. Velocity times time. Normally velocity is displacement over time. True or false? So to get velocity times time is going to give me the displacement. So since the area of this graph is length times breadth, which is still velocity times graph and velocity times time, what is it equivalent to? It is equivalent to the what? To the displacement. So now the question I asked that the distance traveled is determined by what? The area under the graph. True or false? Because the area under the graph is length times breadth, which is velocity times time, which is still the same thing as even when you use the formula. Velocity times time, you still give it the displacement or the distance. So the answer is area under PQR. Is that understood?
Yes, sir.
All right. So question 38, we've answered a similar question. So what do you think happens when light moves from a less dense medium to a denser medium? What happens with light? Somebody.
Bend away from the normal.
No, that one was different. Yeah, that one was looking at a particular. Yes, if it's moving from a less dense. No. Wait, what did you say? No. The situation is different. I said, let me just follow. In the other question, I said, when you're moving from a denser medium to a less dense medium, it bends away from the normal, right? It bends away from the normal because in the denser medium, it is slowed down. But in the less dense medium, the speed is going to increase. So that means it's going to move fast away from the normal. But when it is moving less dense, that means it was moving faster in that medium. To denser medium, that means the speed is going to reduce. So it's going to bend, it's going to move slowly, and so it's going to bend towards the normal. But in this case, we're looking at other properties of light. Now, basically, this is light wave, right? So they say which of the following, how are the speed and the frequency affected? So let's look at it. Now, frequency is determined by the source of light, right? It does not change when it enters a particular medium. Frequency is unchanged. Even when I was explaining the photoelectric effect, I said that when light shines at a particular metal, based on the frequency of that light, it can cause that metal to emit what? To emit electrons. And I explained why our normal light, like your flashlight, your phone light, you're not seeing the particles because they are not at that particular frequency that will enable you to see the particles in light. So that means the frequency of light does not change regardless of the medium. So the one that says frequency increases, option A, frequency decreases, it is wrong. None of them. Frequency never changes because light is not dependent on the medium. Light is coming from a particular source. You understand? So the frequency does not change. So now let's now see. From the other example, I said when light is moving into a denser medium, what happens to the speed? It decreases. True or false? I've explained that already. Because in a denser medium, the speed of light is being restricted because it's not free. Like in a vacuum, there's no resistance. So it's a less dense medium, so light will move there. But in a denser medium, maybe like water, what happens to the speed of light? That's why if you look at the ocean, light is shining at the top, but you can't see it at the bottom, right? So the speed of the light will decrease. So that means basically, for what I'm saying, the answer is option. The speed will decrease, but the frequency will remain same. But there are three properties of light. There is the speed. Normally in a wave, you have V is equal to F lambda. There's the speed, there's the frequency, there's the wavelength. Now, frequency always remains unchanged. For speed will decrease in a denser medium because light will slow down. Then, for the wavelength is going to do what? Decrease, no matter what, because the frequency is constant. You understand? The wavelengths, you getting it? The wavelength is dependent on the speed. Do you understand what I just said? Now, let me recap. V is equal to F lambda, right? So since this one is constant, just like in your direct variation, that means automatically this is direct variation. This was directly proportional to this, then the constant was brought in. So that means the wavelength depends on the speed. So if the speed reduces, what happens to the wavelength? It will reduce. If the speed increases, what happens to the wavelength? It will increase. So now, since light is moving into a denser medium from a less dense medium, the speed reduces and automatically wavelength also reduces. So, question 39. What is the function of a fuse? Basically, is to break the circuit when a particular current rating is exceeded. That's why you always hear people talk about the need for you to fuse your appliances or to use a fuse so that your appliance is not being damaged by excessive current. So let's look at the options. It says break the circuit when current exceeds a particular value. Of course, that's the answer. It does not save energy. It doesn't do the rest. So the answer is option A. Now, question 40. A body moves with uniform velocity when the resultant force on it is dash. What do we think? What do we think? What do we think? This question, I think it's from 2004 Waec physics. Yes, go on.
It's greater than the frictional force.
It's greater than frictional force. Okay, greater than frictional force. Okay, that's one option. Somebody else, anybody, somebody, please.
It's less than the frictional force.
Okay. Okay. Any other person? Okay, we've had, I think, equal to 0. Equal, okay. We now have a third option, equal to 0. All right. So let's now see which of these options are correct. So thank you, first of all, for engaging. You are really trying. So we're told that the body moves a uniform velocity, right? So what would be the resultant force on it? Now, basically, what's going to happen is that there are two, okay, another idea is possible. There are two ways I can give you the answer. Now, first of all, force is mass times acceleration. True or false? So if there's uniform, now remember, acceleration is change in velocity with respect to time. So that means if there is no change in velocity with respect to time, there's no acceleration. And so that means with uniform velocity, there is no acceleration. Uniform velocity means constant velocity or constant speed. It's not accelerating like a bus moving at a particular speed. It's not accelerating. The driver just maintains that speed. So that means from that formula, since it is constant uniform acceleration, velocity, do you understand? Since the velocity of the speed is constant, that means there is no acceleration. Acceleration is 0. So what happens to the force? Mass remains the same. Acceleration is 0. So mass times 0 is 0. That means the force will be equal to 0. But that just came to my mind. But the actual explanation is Newton's first law. We know that as I was about to say this, that idea just hits me. So the actual explanation for it is just a statement of Newton's first law. Now, what does Newton's first law state? It's called the law of law of inertia, right? It says a body will continue in the state of rest or uniform motion unless acted upon by a net external force. That means, for example, if I keep my phone will continually be at rest unless I maybe lift it up, I push it, or something happens to it. A force changes that state of rest. If I throw my pen up, my pen should continue going up and up and up and up unless it is acted upon by the force, which is gravity, that pulls it down. That means whatever be the uniform velocity of an object, if it is at rest or if it is moving, it will continue that way, provided that no force is acting on it, which means that the force on it is 0. But if the force now acts on it, it now changes the state. Like I said, my phone was on this table. What happened? The moment I lift it up, because a force has acted on it, its uniform velocity has changed. My pen that I threw up, when no force was acting on it, it was going up until gravity eventually cut off with it and then hold it down. So those are the two methods you can use to explain the answer. So the answer is actually equal to 0. So do we get it? Is it clear? Is it clear? All right. Let's go on. Question 41 says the law of conservation of momentum is stated that for a closed system, what two conditions must be met? What are the two conditions?
No external force are moving the mass.
But basically, mass does not change, right? To all the other options, B and C are already knocked out. But B says gain in mass, C says loss in mass, so they are already out. So in a closed system, there must be external force acting on it. So the D option B says there's an external force, so that's already out. So the answer is option A. That we no external force at the same time, we don't change the force of the force. Question 42 says.
Hello, Mr. Chike. Hello, sorry to interrupt you. You need to round off so that they can rest and prepare for cell rest class, which is starting at 12:30.
All right, so we'll just round off with this one. Okay, let's just round off with 42 and 43. So for 42, we said we should calculate the tension in the string. We should calculate the tension in the string. Yes. So first of all, we need to calculate the centripetal force, right? And what's the formula for centripetal force? It is mv squared over r. Let's go. What is the mass? 200 grams. Now notice that is not in the standard unit. That's not in the standard unit. Standard unit for mass is kilogram. So I'll convert 200 grams to kilogram by dividing by 1,000, which will give me 0.2. Times the velocity. What is the velocity? 5, which is v squared, all over the radius is 1.5. So what does it give you on the calculator? So 0.2 times 25 is 5. It gives me 3.33. So the answer is option. Now, basically, they told me to calculate the tension. So why then did I calculate the centripetal force? Now, what happens is that when you have a circle, like for those that have watched a movie of a slingshot, you take up the sling and then you roll it and roll it and roll it and roll it. You discover that there is a force that is keeping that sling in that circular motion. So that force is provided by a tension in the string that's dragging it towards the center. And that force that keeps that object towards the center is called centripetal force. So the answer is, for the tension, it is equal to the centripetal force that is keeping it in that circular motion by pulling it towards the center. So the last question. Question 43. Well, I think this is one of the most popular questions on current electricity. So what's the answer? It should be easy. How do we convert a milliammeter to an ammeter? Now, a milliammeter measures smaller current than an ammeter. So what do we do? Yes.
Low value in parallel.
Low value in parallel, correct. So because you want to measure so because you want to measure tiny current, right? So to measure that tiny current, you need to add what? You need to add low value of what? Of a resistor in parallel. Now, if you connect in series, there will be an increase in resistance. Remember, in series, that's end to end, and it will add up the effective resistance. So anything series connection increases the amount of resistance, and resistance or resistors oppose what? The flow of what? Of current in a particular circuit. So if you have to connect the resistor in what? In series, which is contained in option A and option B, what happens? You are increasing the resistance to the flow of what? Of current. Then of course, normally you want to reduce the resistance because according to the question, you are trying to get a milliammeter. An ammeter measures current. So that means if you have to connect a resistor, you will not connect a resistor of high resistance. It has to be of low value so that it does not resist a current. And then it has to be parallel because in series, just like if they connect 3 ohms and 6 ohms in series, the effective resistance is 9 ohms. That's high resistance. So that's why the correct option is option C. So is that clear? Class, is that clear?
Yes,
Yes,
sir.
Oh, so you have step. So let's just end the class so that we'll be able to. I believe we'll be able to finish up. But because looking at it, we only have one class. Please, what we'll do is that I think there was a method we used in the last session to pick up questions of interest. If you see have the link, right? You see have the link on your platform. Go through the questions. So please, very, very important, so that you'll be able to move fast. So over approach. So please, you go through the questions again, and then you let me know the particular ones that are of interest or idea. So far, do we get what we need today? All right. So thank you very much. So let me allow you to have your rest. So see you in the next class. Do you have any questions?